Ritika, just let me know, is the screen sharing or not? Because from my side, it's showing that screen is not sharing. Now,
It's
please check.
sharing, ma'am.
It's sharing now.
I can see it.
Now see, yes, Siddhika, screen is sharing. No? Now it's fine.
Yes, ma'am.
Okay. So see, gravitational energy also, when we talk about gravitational energy, potential energy is concept we have already discussed, right? So here also work done we have to calculate. See, suppose this is a mass. Mass is m, which is given. Fine. Now there is a point infinity where m can be placed, and in between infinity and this point there are 2 points, A and B. There are 2 points. So this separation from this point, no, of calculation, this I have taken. Suppose, let me take something as x. This is the separation from this point. And the separation from the final point, let's say from this AB, I'm finding the potential energy to a point in between, let's say P. And separation of P from the center is R. AB is just a small separation which I have taken in between, which I will expand till P. All right, clear? AB is just small 2 points which I have marked, which I will expand till P. P is the point at which I want to find out. See, work done from infinity to P. This is my question. This is the case that I have right now. From infinity, I have to bring up the charge to the point P. So this is potential energy at point P. We have to bring it. Now the forces G, capital M, into small m divided by, what's the separation? Right now the point is at infinity. I have not brought the point to point P. Right now I'm calculating the point, not at infinity, sorry, at this point A. So at this point A, gravitational force, it will be x square, because this is the separation I have taken from point A to this mass. So this is gravitational force at A point. All right. Now see class, when I say work done in between these 2 points which I have taken in middle, that is AB. This is force into displacement, that is force F dot dx, which is F dx cos 0 degree, or simply F dx, force into displacement. This is easy to remember. Now, if this is the formula of work done, I already have the formula of force. Formula of force I have kept. I should substitute the value of force into this so that I get the value of work done. See, forces formula is being calculated. M, small m is there, capital M is there. Both the masses are present. So they are separated by a certain separation. And I have calculated at the point A the force to be as Gmm by x squared. When I'm calculating the force, when I'm calculating the work done is force into displacement. So now I already have the value of this force. No, I already have the value of this force. So I'll substitute in here. I should substitute this value to find out the actual work done. So work done will be Gmm by x square dx. And now I will integrate this. I will integrate this. See, from where should I integrate? From infinity, I want to find out it till point P. But I cannot write a point P. Point P is nothing. That's not a distance. That's not a separation. So for finding out the separation, we need the separation from the center, which we have already marked it as R. So this separation, so ultimately what are we integrating? You are integrating from infinity to R. R is basically representing you the point P, which we are calculating. Now coming to the basic integration, look here, capital G is universal gravitational constant. It will be constant. Masses are already constant. So we can at least, for work done, keep these term aside. Now what are we left with? 1 by x to the power 2. we can reciprocate it to integrate, right? We have to integrate it. So we can reciprocate this term. That becomes x to the power minus 2 dx, integrating it from infinity to r. All right. Now, basics of integration. Again, I'll repeat the rule for those who do not remember. X to the power n is present. What you do, x to the power n is there. Just add 1 to the power, and now whatever power you have obtained, divided by n plus 1. So this x to the power n plus 1 it gets divided and it becomes n plus 1. Fine. Now see, so if we have it here, GMM, this becomes x to the power minus 2 is there. What did I say? Here your n is denoted by minus 2. So plus 1 is added to the power. So here also plus 1. And now what is the power that I have obtained? Minus 2 plus 1. If I have obtained minus 2 plus 1, this will come as it is in the denominator. All right, integrating it from infinity to r. So this is x to the power minus 1. And in the denominator also there is a negative sign. So what we can write down work done as minus GMM, minus because of this sign. And x to the power minus 1, we can write x to the power minus 1 as 1 by x. Integrating it from infinity to r. Now we just have to put in the values of x. Substitute in the values, upper limit minus lower limit. So work done is going to be minus capital G, capital M into small m, 1 by r. First you put in the upper limit, minus 1 by infinity. Then you put in the lower limit. 1 by infinity. Can anyone tell me what is 1 by infinity equal to? Is there a specific value for 1 by infinity? Or it's not defined? It's any idea?
Not defined.
It's 0. 1 by infinity. No, always remember 1 by infinity is 0. This will be very helpful for your calculations in any question wherever you have 1 by infinity. That will ease your calculations because directly it will become 0. All right. So finally, if this term becomes 0, work done is minus GMM by R. This is the work done. Now see, this work done gets stored in the form of potential energy. So what is left? Potential energy will become minus GMM by R. Right? So if, for example, here two masses are present, M1, M2, they are separated by a certain separation, that is R. So they'll be having the potential energy is minus G M1 into M2 divided by R. Now there is a significance for this negative sign that we have finally concluded. This negative sign, which is coming in our calculations. This negative sign. This negative sign, though I think I have already discussed the concept of potential energy, negative sign, bounded system, unbounded system and all with you. A very quick revision for the negative sign states that the forces are attractive in nature. This basically denotes the fact that the forces are attractive in nature. So this means what? Both the masses are present. Both the masses are exerting gravitational forces on each other according to Newton's law of gravitation. So both of them are attractive in nature. And usually in gravitation, we have attractive forces only. Gravity will attract only. When we come to electrostatics, there you have charges and the polarity of the charges can differ. So like charges will be repelling each other and unlike charges will be attracting each other. It's a very basic concept that you must have had studied in your lower classes. But regarding masses are usually attractive in nature. That's why the system is bounded. If in our universe, the negative sign becomes positive sign in your calculation here, then the system cannot remain bounded. For the system to remain bounded, the forces have to be attractive in nature. And that particular magnitude has to be abided by every formula of force. All right. So that's why this negative sign indicates that the forces are attractive. This basically shows that forces are attractive. All right. Yes, one more thing before we start with the questions part. If suppose the separation between two planets, this is infinite, though whatever planets we consider, they have a certain separation. If I take the separation between Earth and Sun, there's a separation. It's just that we define it in terms of astronomical units, or we define it in terms of light years. We do not use the simple units for our calculations, which we have been using in motion in a straight line, like meters, centimeters, not even kilometers. We prefer to write it in astronomical units or in light years. So there's a conversion which you should remember, that as soon as the questions will come, I'll tell. But it can happen, no? Some planets are separated by infinity, or something is there which I separate it by a separation of infinity. So what happens? 1 by infinity is 0. And if potential energy is coming 0, it means the planets have been completely separated off. So see, this is not negative. This is showing that the planets, or any two bodies, this is not just about the planet, it's just that planets are the suitable example for this. If two bodies are getting separated, so this is not the force of attraction. No more the force of attraction is working. This is force of repulsion. So this way also you can remember how to remember the negative sign and its significance, because in some questions you will get to write the definition and to derive the entire formula for potential energy, and ultimately deduce the importance of negative sign. All right. So potential energy will be maximum when the separation will be infinite, because it was negative. So whenever you are increasing the denominator, potential energy will also be increasing. Why? Because negative sign is there. Lastly, whenever this, we have done so many times, work done to make the system, work done to break the system, laws of motion, work, energy, and power, we have been doing this concept. Work done to make your system is positive of potential energy. Work done to break your system is negative of potential energy. This will be helpful for your calculations. And one more thing, work done to make is negative of work done to break. All right. Note down all the concept and mark this derivation as important. This derivation is important. This can be asked to you in your exams. Note it down. Any doubts if you people have, you can in between ask. See, in this question, you have two masses, 2 kg mass and 3 kg mass. Both the masses are present and they are separated by 10 meters. You have to find out potential energy of the system, work done to make the system, work done to break the system. So the question is not difficult. Formula based question it is. M1 is 2 kg, M2 is 3 kg, and separation is 10 meters. So U is equal to minus G M1 M2 by R. G is the universal gravitational constant, 6.67 into 10 to the power minus 11. First mass is 2, second mass is 3 kgs. They are separated by 10. So this is 36, no, so around 37, let us take minus 37 into 10 to the power minus 12 joules. This is the potential energy. So work done to make the system will be exactly this. Work done to make the system will be exactly equal to this. That is minus 37 into 10 to the power minus 12 joules. But work done to break the system, it will be negative of this. So that this minus sign, no, this will become now positive. So answer is plus 37 into 10 to the power minus 12 joules. Note it down. Now, some figures we will see, some unsymmetrical figures if it is given. Write it down.
I'm gonna go up. I'm gonna go up. I wanna see third one.
Completed. Done, Martin?
Yeah, ma'am. Yeah, ma'am.
See, the next question is, I would just want to ask one thing. Rest of the portions I'll solve myself only. These are four masses which are given to you, and this is not a symmetrical system. We know the figure is symmetrical, that is, it's a square having equal sides. But since all the masses are not same, the magnitude of all the masses are not same, so we cannot conclude the fact that this is a symmetrical, it's an unsymmetrical system. None of the masses are balancing each other. I just want to ask you, how many potential energies will be there? See, when two masses are present and they are separated by a separation, we call this as one potential energy existing between them, one force of attraction between them. So how many, all of you, answer me in the chat column right now. How many, like, see, M, one hint I'll give you, 1m and this 2m. This makes up one potential energy, one interaction. And potential energies basics involve forces of interaction. So how many interactions are present according to all of you? Yes, Abdullah, Alia, Martin, Siddiqa. Your answers, whatever answers you people are getting. Rest of the part, I'll discuss it myself. Okay, Siddiqa has answered. Other students? Alia, Abdullah, Martin. Alia has also answered. So Alia and Siddiqa have answered. Abdullah and Martin, your answer. Count it and let me know. Number of interactions you people are assuming. See, please answer it, because how will I proceed then without knowing what are your basics? Martin has also answered. Yes, Abdullah, you are present or not? You're attending the class or not? Otherwise, I'll remove you if you're not present. Yes, Abdullah Muhammad. Yes or no? Because once you are removed, then it will be difficult for you to attend the class. All right. Now your answer is right, Ali. Correct answer. Now your answer is right. It's 6, not maybe. This one answer is correct. See, 4 you people are absolutely correct. When you people are answering 4, see, whenever you're saying 4, this is first, this is second, this is third, and this is fourth. This is how you people must have answered. Alia is right. You will also consider them also, no? 4m and 2m are also interacting. M and 3m will also be exerting force on each other. So here also potential energy will be generated. And here also potential energy will be generated. So 5 and 6, not 4. That's why I was asking to know what you people have studied. All right. Now, see, these are the 4 masses which are present. So, potential energy, when we are talking about potential energy, first interaction when I am considering. So what's the general formula? G m1 m2 divided by r. So capital G is there, and yes, of course, negative sign. So minus G, first mass is m, second mass is 2m separated by a. All right, this is first. G m 2m means G m1 m2 divided by minus G m1 m2 divided by a. Fine. Secondly, this separation. This becomes minus G. First mass is 2m, second mass is 3m divided by a. All right. Third one, this is the third one, minus G, 4m multiplied to 3m divided by a. Fourth one is this, minus G m into 4m divided by a. Now, what about this diagonal? See, this diagonal is what? Under root a square plus a square. This is what is the entire diagonal, that is a root 2. Similarly, under root a square plus a square, that is a root 2. So this separation is a root 2. So this becomes minus C. When we are writing fourth one is minus G m into 4m divided by a. Fifth one is minus G m into 3m divided by a root 2. And last one, sixth one, minus G 4m into 2m divided by their separation is a root 2. So minus G 4m into 2m divided by a root 2. Fine. Now let's take minus G m square by a common. So minus G m square by, from here 2 is left, minus G m square by, from here 6 is minus, minus we have taken common, so plus 2, so plus 6 is left from minus G m square by a, so minus has taken common, so plus 12 is left. Plus 4 is left, plus 3 by root 2, plus this is 8 by root. So yes, 10, 12 again, that becomes 24. See, what is the final answer? The final answer is, look here, minus G m square by a. This is 24 plus 8 plus 3, 11 by root 2. This much joules is the answer. Write it down and try to solve it by yourself. Whenever you get stuck, then look at the screen. Solution is there. Abdullah, where were you? The above question, first question. Please inform and leave, not Abdullah. Otherwise, how will I know whether you're present or not? I was calling your name. I had called your name thrice. Just inform and leave so that I also have an idea. I'll not call your name. The first question you are referring, Abdullah, the question we did before this? Or you want me to explain this? Okay, I'll show you. Let me show you that question. Question you have written, solution you want, or the question as well? Completed by now? If anyone is writing, just let me know. I'll scroll up back. See, potential energy difference. This is very easy once you already are aware of potential energy. Potential energy difference means what? You have a final point, you have an initial point, you're taking the difference, right? So it's just that in your exams, no, this derivation comes for sometimes for 3 marks, sometimes for 4 marks. And with one more question, it can come for 5 marks also. So that's why we are doing it separately. Otherwise, this is not a very different concept to understand, to study. So this is change in potential energy. Now change in potential energy, UB minus UA. So again, see, this procedure will remain same, Gmm by x square dx. It's just that now you have 2 points, R1 and R2. It's not infinity when we are calculating this derivation. That's the difference. Just 2 points are there. 1 point is not situated at infinity. So this is, you are integrating from R1 to R2. So rest of the steps will be the same. GMM will be taken x to the power minus 1 dx from R1 to R2. This will be taken, and see here. Again, I've told you, this becomes GMM x to the power minus 1. No, this is minus 2, sorry. Plus 1 divided by minus 2 plus 1, integrating it from R1 to R2. So this becomes minus GMM x to the power minus 1 from R1 to R2, which you can write further as GMM by 1 by x from R1 to R2. It's just that in the previous calculation, when we had written it, this was 0 because of 1 by R2. Right now, 1 by R2 minus 1 by R1, this is not coming 0. This is the formula which you have to remember. So R2 is the final separation. This is the final separation. And this is the initial position vector also, you can see. So this derivation also comes. That's why I'm discussing this. Write it down. See class, when we are talking about potential energy, there is one term that is just gravitational potential. So gravitational potential, no, it's also work done, but work done when you're defining one particular mass. Just understand the concept, otherwise this is very easy, not difficult. And it's also important, and as I've told you, the way you have this lesson, synonymous lesson you have in your class 12. So gravitational potential, it's a basically scalar quantity, work done in carrying unit mass. So just don't go by the definition. This definition is lengthy. This definition you ultimately have to write in your answer sheets. When we're talking about gravitational energy or entire work done for just one single unit mass, which is the test mass, that is known as gravitational potential. So it's the work done in carrying unit mass from infinity to a point against gravitational field. That's it, what you have to remember. Now potential of, and yes, what has been written here is source mass means one that is generating potential. Now what will happen? There will be a shield. There is a field. Gravitational field we have studied. See, yes, gravitational field we have studied. Gravitational field was vector. This is just a scalar form of gravitational field as it is. Rest of the concepts will remain the same. You bring a test mass, you will feel forces of attraction in this sphere. That is what is meant by it. Potential of mass m at P. Now see, this what I was telling you. Work done in carrying mass from infinity to a particular point P. This is work done divided by mass. So this is exactly the formula. Now see, if I make this as unit mass, this is the generalized formula. If I make this as unit mass, 1 kg. So entire potential will be equal to work done. Now can you remember the definition? Gravitational potential is the work done to bring a unit mass from infinity to a point, particular point. That's it. This is how you can remember its definition also. And SI unit, use this formula. This formula is very helpful, class. Work done per unit mass. You'll have a similar formula, work done per unit charge also. So that's why I'm saying this lesson is just very similar to it. All right, gravitational potential of a point mass minus these formula part we'll do together. Write down these first. Formula part we'll do together. You have to write it for hollow sphere and all. Write it down first.